Welcome back to the C++ course. This is chapter 12, more on C strings and the string class. Some miscellaneous topics in this one, some interesting techniques and ideas for dealing with strings, for dealing with pieces of text, as oftentimes does happen in the code that we write. We need to manipulate sequences of characters in certain ways, and C++ gives us a variety of ways kind of out of the box to do this. There's no reason for us to have to reinvent the wheel if we want to do things like, substring or string substitution, concatenating strings together. A lot of this type of functionality is baked in to the C++ language. Our list of topics for today, we're going to take a look at character testing, character case conversion, old school C strings, how the C language treated strings under the hood. We'll take a look at library functions for working with C strings, conversions between numbers and strings. This happens all the time in programming, having to convert between a string representation of a number to the literal number and vice versa. We'll take a look at how we can write our own C string handling functions and a little bit more about the C++ string class. Not a huge list of topics for this lesson, so it'll probably be a shorter lecture, hopefully. Character testing. So we do have access to functions to determine information about the value of a character. Usually when you utilize these functions, you pass in HR, the character that you're wanting to test or know more information about. Typically these functions return non-zero value or zero representing true or false. And you must include the CC type header file to use these built-in functions. So character testing, here's a basic table of those functions. They're also, of course, found in the textbook and online as well. So they're very, very simple functions. Simply is alpha, passing in a character, returns true if the argument is a letter of the alphabet. Is digit, returns true if the argument is a digit 0 through 9. And a lot of these things are kind of commonsensical type things we might want to know when we're dealing in particular with like string input or character input from users. If we're saying, here's a menu user, enter values 1 through 9 to select a given item in that menu, obviously we're going to have to test to see if the data they entered is a digit. If it's not, we need to reprompt them to enter valid input. And a lot of these functions can help us with that. You can even test to see if input is lowercase or uppercase. You can check to see if it's a printable character. Is it a space? Is it punctuation? So like I say, a lot of kind of commonsensical type built-in functions here we can use to test our characters with. Functions can be used to validate the data format, as I was just saying. So here we have a little Boolean. And again, this is testing input, so validating data format. Valid equals false. So in this case, when we hit this line of code, we create a little Boolean flag called valid, and we're initializing it to false. So we're assuming that the input or whatever data we're dealing with is invalid. Then we're going through our check, our tests here. And what we're doing here is we're chaining together a lot of these character testing functions to produce a Boolean. And we're utilizing the ampersand, the and Boolean operation to chain these together. So we're going to say, is the part num, there's some array here, part num array at location 0 a digit, and is it upper, and is the second index, so character 3, of the input a digit. All these must be true for this input to be considered valid. Remember back to our Boolean logic lesson, if any one of these fails, then the entire if statement fails and valid, stays false by the time this if statement makes it all the way through. So this is one example of how you can chain together these checks to create basically a data validator for whatever use you may have. But again, this is like a part num array. We don't really know what that means. Part number, digit, uppercase letter, and a digit. So that's the format that whoever wrote this code is kind of enforcing. And this is our method of checking that. Now, probably every time you wanted to test a part number, you wouldn't have to want to go through this complex, I would call this a complex if statement every single time. So as you know from our functions lesson, probably it would be a good idea to package this chunk of code up in a function and call it valid part number, returns true or false, and inside of that function you would see this if statement and the function return true or false based on if the given input is valid. Little hands-on exercise to get our hands dirty here right away. Page 822. Uh, 12-1. Let's see. I need a new console app. Project name. EX 12-1. Oh, Visual Studio needs an update, as it does almost every single month. That would take some time, however. Alrighty, so as I mentioned, we include IOStream and we include CC type. Create a little char called input, cout, enter any char, cin.get into input, cout, the character you entered is pretty straightforward so far. Getting a character, printing it back out. And now we're going to do some of those basic character checks. So if is alpha, autocomplete helping me out there, passing in input, cout, you entered an alphanumeric char. And because these if statements are so tiny, yeah, we're not going to include the curly braces here. Remember, when you're dealing with little Boolean functions like this, you can say if is digit, passing in input, equals true. Okay, remember that means the same thing syntactically as just saying this. You could say equals true, or is not true, or equals false, whatever you're most comfortable with. Cout. This is probably what you would see more in the wild though, so I'm going to try to get us more comfortable with what we're going to see like in real world code. So I will leave it formatted kind of like this. If it's a digit, you entered a digit. If is lower if is upper and you get the idea. We'll skip the last one just for time's sake. Return 0. Run it, and it's possible that because we're using separate if statements, we're not doing like if, else if, we're doing individual checks. It's possible that if I enter like an uppercase A, character entered is A, it is alphanumeric, and it is uppercase. It's not like if one of these checks true, it's going to forget about the rest. It's going to check each of them separately. Next up, test a customer number to determine whether it is in the proper format. Including CC type, including standard namespace. All right, outside of main here, we're going to have a Boolean function. So test num, which is going to accept an array of chars and some int. That is our function prototype. Let's jump to the function implementation before we go into main. Test num is right here. This is kind of doing what I was talking about in the PowerPoint about externalizing your data validation checks into separate functions so they're nice and easy and compact to call from within your main function or other areas of your code. Bool test num accepts an array of chars called cust num, an int for the array size. We'll create an int called count, which is our loop counter for count equals 0. Count is less than magic number 3, count plus plus. And in this, we're going to do a check and say if not is alpha customer num at location count, return false. Okay, if at any point this is false, if is alpha is false, return false. Notice because of the return statement, the function returns. We're not going to continue iterating the loop. We're not going to go on to the next for loop in this function. We return false. We're breaking out of the function at that point. Then we for count equals 3. Count is less than size minus 1. Count plus plus. Test the remaining characters for numeric digits. So notice here, we're testing the first 3 for alphanumeric, then we're testing the remaining characters for numeric. So it's just some kind of made up arbitrary validation rules that we've pulled out of thin air, really. If not is digit cust num, so at location cust num, at location count. If that is false, return false. Otherwise, just keep going, keep iterating, and if by the time we make it through both of those for loops and we haven't returned false yet, we're going to return true. Now let's fill out the main function. Const int size equals 8. An array of characters. Cout, enter a customer number in the form LLLNNNN / new line. Okay. Cout, a little more prompting for the user here. Paren LLL equals letters and NNNN equals numbers. Closing paren, colon, space, semicolon. All right, cn.getLine now into customer, and the stream size is our size constant. If, we'll call our validation function we just created, if test num on customer size. If that returns true, we'll see out valid. Else invalid. And they put some more prompting there. We'll return 0, we'll run this thing, and we'll see what kind of output we get with the textbook's input. All right, first prompt here, RQS 4, 5, 6, 7 is a valid customer number. About AX 4, 6, 7, T9 invalid. Looks like we are successful. All right, character case conversion. So functions to convert uppercase letters to their lowercase equivalent and vice versa. We pass in a char, we return a char, and again it requires the CC type header file. And here they are, 2 upper, 2 lower. If it is lowercase, return the uppercase equivalent. Otherwise, just return the argument that you passed in. So if you pass in an uppercase, it's just going to give that back. It's not going to like do any conversion of the already uppercase letter. It's just going to spit it back out. It can be used to simplify data testing. So remember back in the day when we were talking about like input loops, we oftentimes had to check each y, so an uppercase or lowercase y, uppercase, lowercase n. That maybe took the form of two separate checks, two separate if statements, but you can make it into one if you just use this toUpper function call. So you can say if toUpper response equals the uppercase letter y. If they pass in a lowercase, it will convert it to uppercase, check it against the uppercase y. If they pass it in as uppercase, it won't matter. It's not going to be processed by toUpper. It's just going to be returned as uppercase y. So you can use that to simplify your checks a little bit. And we'll take a peek at a hands-on. 12-3, let's do this like a read-only type of thing. So calculates the area of a circle, asks the user if he or she wishes to continue. A loop demonstrates the toUpper function repeats until the user enters y, n, or n. Lowercase, uppercase, lowercase, uppercase. So here we have just some variables that we might need to calculate the area of a circle and a char that represents if we want to basically have another calculation. We're going to use the do while loop here, and the user is going to enter in the radius, and that is all the input that we need. So we can take the area equals pi times radius. Remember from your algebra or geometry classes, pi r squared. That's not the point of this listing though. The point is to check out this part here. So cn, go again, and this may look kind of strange. Remember, we have this do keyword above, while down here. And then we see a nested while loop inside of it. So validate the input. While toUpper go again is not equal to uppercase y and it's not equal to uppercase n, reprompt. So if I ask, do you want to go again, and you enter in a, this while loop is going to catch that and keep going until they enter an upper or lowercase y or an upper or lowercase n. Once we have captured that valid character, then we're going to jump down here to this while check and make sure that they've entered in a y to go again. Otherwise, we'll just drop out. Pretty straightforward. This chapter, I would say, generally speaking, is a nice little reprieve from our last chapter, which we did was on advanced object-oriented programming. Hopefully that is of a benefit to you. C-strings. So what is a C-string? It's a sequence of characters stored at adjacent memory locations terminated by the null character. This is the way, as the name implies, this is the way the old C programming language handled strings under the hood. And it looks like this. It's really just an array of chars. So if you have the C string hi there, capital H-I space, that is a character, there, exclamation point, would be stored like this. So you have H-I space T-H-E-R-E, exclamation. Then this is kind of the key here. The last element in a C string array is going to be this null character, which is represented by /0. That's just a special character that's interpreted to mean this is the end of my character array. Let's check out 829. Okay, so define variables that are pointers to the char. Now I think I'm going to pull this one up and actually code it because it does deal with pointers. Let's get a little review of that. All right, using namespace std. Got our int main. All right, const char, pointer to char, called p is equal to null ptr, and then a pointer to an int called q is equal to the null ptr. We're parking these pointers when we initialize them. Then we'll assign the string literals to the pointers to char. So we can do this because of what we just talked about in the PowerPoint. We can say this pointer to char p equals the string hello. space, and then Q, this pointer to char, equals Bailey. Then we can print out cout P, cout Q, cout Endel, like so, and then we can cout P, print the pointers in C strings as addresses. So check this out. We can print out that, then that is stored at, then we can print out cast P to an int Endel. Just to format it a little bit more nicely, that memory address will print better if we cast it to an integer. And then Q is stored at int Q Endel. And then we can do cout string literal stored at int literal. That's a new string literal, which we're treating like a pointer. Return 0. Let's activate it and just have a look at what we have in our output. So this is good. Notice the memory addresses are fairly adjacent here. If you did the math on those memory addresses, you would see that these do indeed represent contiguous areas of our computer's memory. And the last one here also is fairly close. So that's, I guess, interesting. We created all these pointers and they happen to be not happen to be. The first two, it's definitely good that they're in contiguous memory. The last one just kind of happened to be fairly close as well. All right, 831, we'll jump right into the next one. No pointers here, let's just kind of read it from top to bottom. The program cycles through a character array, displaying each element until the null terminator is encountered. So this is kind of proving what we saw in the PowerPoint about a C string ending with the null terminating character. So we've got a constant called length equals 80. We're creating an array of characters of size 80. We're reading a string into the character array. We're prompting, enter a sentence of no more than length -1, so 79 characters. Get line. The sentence you entered is, and here, this is kind of the piece that we care about, we're going to loop through the array, printing each character, one character at a time. Yes, that's tedious, but just to illustrate it, we've got our for loop, index equals 0, line, keep looping, while line at location index is not equal to the terminating character. So I will point this out. Usually when we talk about characters, we have two single quotes and then like one character inside of it. Here you see two though. Here you see a /0. That is a 0, and that is treated as one character. So we might think of that as like a string because there's more than one thing inside of the quotes. But in this case, it's a very special terminating character that is composed of two characters, I guess, for lack of a better term, and then index ++. And that is the terminating condition of that loop. We're not like using a counter or anything. We're using string or a character comparison to actually escape. So speaking of null, what is it? So here the null character is used to indicate the end of a string, can be specified as the character this, the int value 0, or the named constant, capital N-U-L-L. All of these mean null character. All right, so how do we represent C strings? Well, we can use a string literal like this, so a set of double quotes, hi there inside of it. A pointer to a char, we just saw that in a hands-on or two ago, and then as an array of characters. So if we use the pointer to char, this is probably the method that's most uncomfortable for you. But really, when we have an array of characters, we can say, here's a pointer to char, just point at the first character in the string. And then we can use pointer arithmetic to like add 1 to the pointer to get at the next letter and the next letter and so on. So all three representations are pointers to char. So a string literal, or also known as a string constant, stored as a null terminated array of char, as we've been seeing. The compiler uses the address of the first character of the array as the value of the string, and the string literal is a const pointer to char. Okay, value of high is the address of this array. Here's your null terminating char. So more on array of char. Can be defined and initialized as a C string, so you can set it up like this. So here we're saying we have an array of chars that can hold 20 characters, but when we initialize it here, we're just going to take up basically the first 2 slots in that array of chars. Here we're not specifying a size. By default, the size will be however many characters are inside of the double quotes. An array of char can be defined and later have a string copied into it. So we can basically declare a string, a str3, which is a char array, has 20 slots, enter your name, and then using cin.getLine, we can fill that guy up with 20 characters worth of input. So the name of an array of char is used as a pointer to char. Same thing. So when you remember from our arrays and our pointers chapter, if you create an array of char, you're really dealing with a pointer to char. Unlike a string literal, a C string is defined as an array. It can be referred to in other parts of the program by using the array name. So here's your pointer to char syntax, defined like this: char, asterisk, and then the pointer name. Definition does not allocate string memory, used in referring to C strings defined as string literals. So if you do something like this, here remember PSTR is a pointer to char. You assign it the string literal hi there, and then you can print it out like this. Pointer to char can also refer to C strings defined as an array of char. Pretty straightforward again. So you have your str char array, size 20, filling up the first 2 slots. You create a pointer to a char and assign it str. Remember, these 2 are actually equivalent. This is actually a pointer to char. It's just pointing to the first char in the char array. And if you see out pstr, you get the text hi. And you can dynamically do this too at runtime using the new keyword that we've already been through. Take a look at 832. All right, so the program illustrates dynamic allocation of storage for C strings. This is nice because we don't have to know the size of the array at basically compile time. We can decide it later at runtime. However, we have a name length equal to 50, creating a pointer to a char called pname, assigning it, basically parking it to the null PTR. We're going to allocate the array, read in the string, display the string, delete the memory, and return 0. Remember, remember, remember. Anytime you see a new, you must use a delete. In this case, because new is an array, we use delete and then array syntax. We don't want to have any memory leaks or also known as dangling pointers hanging around in our code. Okay, some built-in functions for working with C strings then. We already talked about some built-in functions for working with chars, but there are some that will help us work with C strings so we don't have to basically reinvent this basic simple functionality. So the functions take in one or more C strings as an argument, which you can pass in a variety of ways. You can pass in the name of an array of char. You can pass in a pointer to a char, or you can just pass in the string literal. This is probably the way that's most comfortable for people. Here's an example. So if we have a function called strlen, so string length is what that stands for. You can pass in a pointer to a char, returns the length of a C string. You could also do it like this. This is what I was talking about on the previous slide, passing in a string literal, but it simply returns an int that stands for the size of the string, or the size of the C string, I should say. Yeah, good note here. This is the number of characters in the string, not including the terminating character, not the size of the array that contains it. So if you remember, we have that null terminator, but we're not taking that into consideration when we return the size. Prove it. String length, hello, 1, 2, 3, 4, 5 characters. This prints out 5. Next up, we have strcat. This stands for string concatenation. It accepts actually two pointers to char. One is the destination, one is the source. What does it do? So remember from our chapter on strings, concatenation takes two strings and glues them together. Takes two strings as input, C strings, adds the contents of the second string to the end of the first. That's actually worth kind of remembering. It adds the contents of the second string to the end of the first. It looks like this. If we have two character arrays, str1, str2, good morning, we can strcat, str1, comma, str2. And if we then print out str1, we see good morning. Okay, so it added morning to the end of good. There is, this is classic C and C++. No automatic bounds checking. Programmer must ensure that the first string has enough room for the result. Otherwise, catastrophe. I love this. This is so C++. All right, strcpy. In true C++ naming, we just shorten up names by leaving out vowels. So string copy is what this stands for. Again, we have a destination, we have a source, copies the string from the source address to the destination. So if we have a char array called name of size 15, we can strcopy by taking Deborah, the string literal, and putting it into our C string, our char array. We print out name, we print out Deborah. Again, bounds checking is up to the programmer. 835. Oh, let's jump into our Visual Studio and try this guy. Oops. All right, what are we up to here? Illustrates that you cannot compare C strings with relational operators, although it appears to test the strings for equality. That is not what happens, so a little kind of side note here. Comparing C strings. Yeah, definitely a good one to do as a hands-on. So let's create a const int called length equals 40 char first string size length and second string of size length. We're going to read the two strings, so cout, enter a string, cn.getLine into first string of size length. Cout, enter another string, second string of size length. Now, try to compare stuff. So if first string is equal to second string, cout same string twice. Else not the same. Return 0. All right, enter a string. How about kev? Kev, as you can guess, not the same. Why are they not the same? Let's read. Although two identical strings may be entered, this program will always report that they're not equal because this expression used in the if statement compares the memory addresses of the two arrays instead of comparing the strings of characters stored at those addresses. So, key point here, we're comparing memory addresses, we're not comparing individual characters. Because these addresses are different, the comparison yields a result of false. Even this comparison will, I love this, usually result in false, because most compilers do not check to see if a string literal has been encountered before and will store the two strings at a different memory address. The compiler will then compare the two different addresses, giving a value of false. So really, if we wanted to check to see if these two were equal, we would probably want to create a function that accepted two arrays of chars and just looped through and checked each character by character, and returned true or false. Or you could just use this guy, strcmp, string compare. It again accepts 2 pointers to char and compares the strings stored at 2 addresses to determine their relative alphabetic order. Now, it doesn't maybe sound like you could use this for string comparison, but if we're checking for alphabetic order, we're going to get 3 different possibilities of return values. We're going to see a less than 0, so like -1, if str precedes str2 alphabetically. If they are equal, you'll get 0 back as a return. If it's greater than 0, if your return is greater than 0, str1 succeeds str2, or you could say str2 precedes str1. So you could use this little function here to compare your C strings. It can be used to test for equality like this. So if your result of strcmp, str1, str2 equals 0, you know they're equal, otherwise they're not equal. Now, one thing that you kind of have to just put up with functions like this, like strcomp, you just kind of have to know, or have your C++ manual handy. You have to kind of just know what these different return values mean. Like out of the box, if you just used strcmp, it might not be abundantly clear that if you get a -1 back, that means that str1 precedes str2, or 0 means they're equal, or 1 means one is before the other. So keep that in mind as you're using these things. Sometimes you have to have the documentation up and available handy close by. You can also determine the ordering of these when sorting. So these are case sensitive, as we know from our discussion of the ASCII tables. Capital HI is not equal to lowercase hi. Though you could use some clever trickery and create your own strcmp function that doesn't care about the case of the letters. That would just loop through each character, convert everything to upper or something, do a comparison, and then return true or false. Cannot be compared using relational operators. Compares addresses of C strings, not the contents, as we just saw in our last hands-on. All right, here we're testing for equality with the strcmp function. And from our input here, so this is different than before. Before, we remember we're just using double equal sign is equal. Here we're using I guess you could say a much smarter version of that, which is strcmp, included in the C string library, I should mention. And it's going to check to see if those two are equal. If you enter Alfonso twice, you'll get back true that you entered the same string twice. Here's one. Uses strcmp to compare the string entered by the user with the valid part numbers. So we have price of items. So we have 2 const doubles, A price and B price, 49.0, 69.95. We have a character array for the part number. Part num is a character array of size 8. We have some prompting from the user to enter in a part number that they want. We can read a part number of at most 8 characters here. Determine what the user entered using strcmp and print its price. So we're doing some output formatting here, my favorite, yuck. And then doing a string comparison to part num to this part number that they've typed in. If that is 0, we know that the price is whatever A price is. If this equals 0, we know that the price is whatever B price is. Otherwise, we know that they haven't entered a valid part number. Okay. This guy uses a return value of strcmp to alphabetically order 2 strings entered in by the user. So this may be what you originally thought of when we hit the strcmp slide in the PowerPoint. So we've got 2 char arrays, read in the 2 strings, print the 2 strings in alphabetical order. So here are the names of them sorted alphabetically. So if strcmp name 1 and name 2 is less than 0, we're going to print out name 1, then name 2. If it's greater than 0, we're going to print out name 2, then name 1. Otherwise, we'll know the result of this string comparison equals 0, and we know that that means that they entered the same name twice. Oops. All right, good stuff here. Conversions between numbers and strings. So the string 4326 is a string 4326 without double quotes is an int. And this is something that hopefully is obvious to us by now. It is not obvious to those who don't know anything about computer programming. This is really what kind of shows if you know the difference between data types and what you can do with the different data types. Like you could use all those string comp and all that stuff that we just talked about on this guy. You could not with this guy. You can do math on this guy, but you could not do math that would do what you expected to do. You could not do on this guy. There are classes that can be used to convert between string and numeric representations of numbers, and you need to include stream header file. So the conversion classes look like this. So isStringStream contains a string to be converted to numeric values where necessary. You can do it like this. Use str parens s to initialize the string to contents of the string s. Use the stream extraction operator to read from the string, and then oStringStream collects a string in which numeric data is converted as necessary. Use the stream insertion operator to add data onto the string, and then str open close paren to retrieve the converted string. Numeric conversion functions are introduced in later C++s. They allow conversion between numeric values and string. This is kind of what I'm more familiar with and comfortable with, as opposed to these guys. I've seen and used these a little bit more than the other ones. Allow conversion between data types. So if you have a toString, you could convert a numeric value to a string. So any numeric value. You could have s to I, so string to int, converts a string to an int. String to long, string to float, string to double. Sometimes this is called parsing. If you have a string representation of a double and you want to convert it into an actual double, that's called string parsing. You're parsing that string into a double or a float or whatever else. Here's an example. So stoi, string to int, converts a string to an int. Try to emphasize that. So here's the signature. Here's the inputs that it needs. It wants a const string reference, so an address of a string, a pointer to a size t, position initialized to 0, and whatever the base is. So here's an explanation. So first of all, the string containing the number and possibly other characters, the position in string where the conversion stops, and the base to use for integer conversion. Here's an example of how it's called. So you can follow along the example here if you'd like to see that conversion. What I would point out though is the string that you're trying to convert, and this is kind of strange coming from other languages, string containing the number, possibly other characters. So you need to specify like what the position is of the numbers in the string that you want to convert, and then like discard the rest. That's why you see in the example here, you can just use one part of the string, extract it, and then convert it. But you do need to specify what part of the string you want to convert. 1212 demonstrates the use of STO, XXX, STOI, or D, or L, any of these. So we have the string str, size t holds the position of the stopping character, and we want to convert the string to a double. So the string, this is a number, so it's a negative value in this case. The string is str in line, okay, just print it out. Then we have double d equals stod, string to double, passing in str and the position pos. The converted double is d, the stopping character is whatever the stopping character is, at position, whatever that location is. You can see the same thing converting to int and converting to int using a binary base. Okay, that call is a little bit different. So notice over here we have stoi, str, and then just like we had up here with the position, down here we have one more parameter. We have str, the same ampersand pos, and then 2 for the base. So binary is base 2. So what we're going to see, I'm not sure how they're going to show this printed out. Yeah, the converted binary integer is 1,4. So they're converting that to binary data, not textual data, but binary data. Okay, writing your own C-string handling functions. When you're doing these, you can pass an array or pointers to char. You can do your own bounds checking to ensure enough space for the results are there. So you can add a little like some guardrails to the otherwise very unsafe built-in C++ methods. You can anticipate unexpected user input as needed. So 847. Program uses a function to copy a string into an array. I like this. So we're going to have a copy prototype here. We're going to have an array of chars and a const array of chars. And from the const, you can probably guess like what array is being copied from, what is being copied to. The second one is probably the one we're reading from, and we're passing in or copying in all that data to the first array of chars. So we're defining two arrays of chars of length 30. We're going to read into the source array. So enter a string with no more than whatever that size is, characters, cn.getLine into the source array. Notice the names. We have source, we have dest. They're kind of in the same order as the function prototype, or the second one is like the source. The first one is the destination. Copy it into the destination array and print it. So our str copy accepts two arrays of chars. And here we're just copying one character at a time until we come to the null terminator. So while the source str array at location index is not equal to the terminator, assign it to the same index of the destination array. Pretty straightforward. All right, this program uses the function nameslice to cut off the last name of the string that contains the user's first and last names. So nameslice accepts one array of char. Let's take a look at its implementation. Here it is. So look for the end of the first name indicated by a space or a null terminator. So int k equals 0, while username at location k is not equal to the empty character, and it's not equal to the terminator, k++. As soon as you do find that, though, k will be set at some value. It'll be set at the index at which that is found. Either the space or the terminating character is found. Then insert the null terminator. It's kind of interesting. If usernames at location k is equal to the blank space, usernames at location k equals the null terminator. So what they're doing here, somewhat clever, they're moving the default null terminator, which as we know is at the end of the array. They're just moving it up a little bit to the end of the first name that's in the array. And then by default, the rest of that array will just be truncated, it'll be chopped off. Pretty clever there. If you can understand how this works and what it's doing, I would say you have a pretty good understanding of C strings. Okay, now into the modern century, I feel like, with the C++ string class. So the string class offers several advantages over C-style strings. You have a larger body of member functions. Calling them is more straightforward and intuitive. You can overload them to simplify expressions, and you do need to include the string header file. Now I feel like we're actually doing modern programming with the C++ string library. So you have class constructors, just like you do with any object-oriented programming idea in C++. You can construct new strings with the string constructor. You have your copy constructor where you can pass in the address of some other string and it'll initialize a new string with the values from another string. You can use the convert constructor, so you can pass in a char pointer that'll initialize objects with values of C strings. There's other stuff you can do too. Hey, these are familiar. We've been using these all along. You can overload the string operators. So this is how you read a white space delimited string into a string object. And here's how you can insert a string object into a stream. We've just been using the standard input-output streams. You can use assignment, so assign the string on the right to the string on the left. You can append strings using plus equals. So we don't have to do strcat or whatever that one was for C strings. We can use this more intuitive syntax. If we add strings together, we're really doing concatenation. Like here too. We can also use square bracket notation with strings to get at individual characters stored in them in array notation. You can use your relational operator for string comparison, returning true or false. Here's just a kind of a simple example. String word 1 and phrase, and word 2 equals space dog. So you can see into word 1, user enters hot. You can see where we're going with this. Word 1 contains the string hot. You can say phrase equals word 1 plus word 2. The phrase is hot dog. You can use your plus equal syntax with phrase and then tack on space on a bun. And then you can loop through your string character by character using the bracket syntax to display hot dog on a bun. Just basically all the ideas, most of the ideas of the previous couple slides summarized in one example here. So string member functions. So here you can convert to a C string by using C_str. You can append, assign, clear, copy, erase, insert, replace, and swap. You can deal with space management by using capacity, empty, length, and size. You can use a substring. You can use find to find things inside of your string. You can use a substring, substr, to like extract strings from a larger string. And then you can use compare to compare them. Let's check out one more hands-on. Demonstrates the use of the string find and insert. This is a good one. So there's my mouse. We include the string library. We have a function called $format, passes in a string. The $format function passes in the original string as a parameter. We say string formatted equals the original. So we're creating a new string based on what the original is. We can use the .find function on the formatted string to find the dot. Find the position of the decimal point. We can, position of the decimal point, we're basically getting an index from that find. We're assigning dp to POS. We're saying, well, POS is greater than 3. Do some math. POS equals POS minus 3, formatted.insert at that position, a comma. So we're formatting these strings by inserting commas. You can see the example down here. This is a very handy little, utility function, I guess. A lot of times when you're displaying data to a user, they would want to see the nice $sign and then all the commas inserted throughout. So all it's doing is checking to see basically 3 groups of digits, excluding the decimal point. Every 3 groups of digits, add in a comma. And then at the end, when you're all done looping, add that $sign at the end and return the string. Up here's what we're calling it. Just input something, display the formatted dollar amount by calling it, and an end line. So conversion to C string. So data and CSTR both return the C string equivalent of the string object, useful when a string object with a function is expecting a C string. So this is really the key. You might be thinking, why do I need to convert like this fancy new string object to an older C string? Well, sometimes you may be using third-party libraries, code developed by other people, maybe older code, that is expecting a C string, but in your code, you're using a bunch of newer, more modern string objects. So if code you're using that somebody else wrote is expecting a C string, you can use these conversion functions to give it what it wants. So here's an example. strcat is expecting a C string, but if we have a string nice day, we can convert it. We want to concatenate have a with nice day. So strcat expects 2 C strings, if you remember back several slides ago. So we can take this str, the C++ string object called .data, that'll convert it into a C string, and that'll make this strcat function very happy. Modification of a string object. So you can append. So you can add things to the end of a string, appends the contents of S to the end of str. So some string .append, pass in another string, tacks it on to the end of that string. Sort of like concatenation, a little different syntax, .append instead of plus equals. You can convert constructor for a string, which will allow a C string to be passed in place of S. So we have a string str, here's the string literal have a space, then you can append on the end of that. You can insert We saw this in this example over here for the formatting of the numbers. You can insert into a string. So SumString.insert at a location specified by position, and then the string you want to insert. Inserts a string s at position POS in the string str. You have a convert constructor for a string, which allows a C string to be passed in place of s. Looks like that. And I think we're done with that rather random, if I might say, presentation on strings and C strings. By the time you see this video, the assignment should be posted. That will conclude Chapter 12. Chapter 13, if I'm not mistaken, is all about more advanced forms of file I/O, so reading and writing files. Always a good time. Until then, I'll say thank you very much, and we'll see you next time.